When installing a 10-foot transformer on a 40-foot Class 3 pole, the need for a guy wire should be carefully evaluated. Several factors contribute to this decision, including the weight of the transformer, the pole's class and height, and potential wind loading. A 10-foot transformer typically weighs between 200 and 300 pounds. For the purposes of our discussion, we'll use 250 pounds as an example weight. A Class 3 pole is designed to withstand loads up to approximately 2,500 pounds. However, this load capacity must be considered in relation to the pole's height and the leverage exerted by the transformer's weight. The pole's height, in this case 40 feet, significantly impacts the leverage effect of the load. The higher the pole, the greater the leverage, and therefore, the greater the stress on the pole. Wind loading also contributes to the overall stress on the pole. The force of the wind increases with height, adding to the bending moment and potentially destabilizing the pole. To understand the forces at play, we can use a simple leverage calculation. The moment, which is the turning effect of a force, is calculated as force multiplied by distance. Let's first consider the scenario without a guy wire. The force is the weight of the transformer, which we're using as 250 pounds. The distance is half the pole height, or 20 feet. Therefore, the moment is 250 pounds multiplied by 20 feet, which equals 5,000 foot-pounds. This calculation suggests a significant bending moment acting on the pole. Now, let's consider the scenario with a guy wire. The guy wire effectively reduces the distance over which the transformer's weight exerts its force. For this example, we'll assume the guy wire attachment point creates an effective distance of 10 feet from the base of the pole. Therefore, the moment is 250 pounds multiplied by 10 feet, which equals 2,500 foot-pounds. By installing a guy wire, we've effectively reduced the bending moment on the pole. Comparing the two scenarios, the moment without a guy wire is 5,000 foot-pounds, which exceeds the allowable load for a Class 3 pole of 2,500 pounds. This indicates that the pole is likely to be unstable without a guy wire. With a guy wire, the moment is reduced to 2,500 foot-pounds, bringing it within the pole's allowable load capacity. Therefore, a guy wire is necessary to reduce the leverage and ensure the pole's stability. The guy wire anchors the pole, preventing it from snapping or leaning excessively under the weight of the transformer and the force of the wind. The installation of a guy wire is crucial for maintaining the structural integrity of the pole and preventing potential hazards. The actual placement of the guy wire, its distance from the pole base, and the size and type of wire used will depend on site-specific factors. These factors include soil conditions, the presence of underground utilities, and any other obstacles near the pole. Firstly, soil conditions play a crucial role in determining the holding strength of the guy anchor. Loose or unstable soil may require a larger anchor or a different type of anchoring system to ensure adequate support. Secondly, the presence of underground utilities must be carefully considered to avoid damaging them during the installation of the guy anchor. Utility companies should be contacted to locate and mark any underground lines before digging. Thirdly, other obstacles, such as trees, buildings, or fences, may limit the placement options for the guy anchor. The guy wire should be installed in a location that provides a clear, unobstructed path to the pole. In summary, installing a guy wire when mounting a 10-foot transformer on a 40-foot Class 3 pole is typically necessary to ensure stability and prevent failure. Consider these factors when determining if a guy wire is needed: the weight of the transformer, the pole class, the pole height, wind loading, and a moment calculation. By carefully considering these factors and implementing appropriate safety measures, you can ensure the safe and reliable operation of the electrical distribution system.